Okay, hello children, how are you? So, welcome to these physics classes. 10th class children should be careful. Well, this first chapter covers almost all sometimes 6 to 7 marks out of 40 marks in your public examination. So, be careful about the first chapter. So, in the last class up to this one, we have learned that is beyond C, on C, when an object kept on C. Now, today we will see between C and F. This is the third case, between C and F. You know very well, C stands for center of curvature and F stands for focal point or focus. So observe carefully the ray diagram because of the time consuming. So before I start this video, I'm drawing. So don't bother about that, and please concentrate while of course I'm drawing on this, overwriting on this. So please, if you have any doubts, please let us know. So first you draw a concave mirror surface, and also then draw a principal axis, and this is the point of pole of the mirror. Next one, what is the condition between C and F? Where is C? This is C and this is F. So in between these two, you have to place an object such as a candle. What is that? So I am placing a candle. From the tip of the candle, according to the principal ray diagram's formulas, so first light ray is parallel to the principal axis, will passes through the focus after reflection. Clear? And next one, the second light ray, I am choosing that the light ray which is passing through the focus will become parallel. Is it clear? The light ray which is passing through the focus will become parallel to this principal axis. Now you will get an intersecting point here. Okay, and draw a candle diagram like this. Okay, and by seeing it easily, already you have that experience, knowledge of these two, easily you can draw or write the characteristics of this image. What is the first one? It is a real image because it is keeping or falling in front of the mirror. And the second one is what? The size is enlarged comparatively with the object. So what is the size? It is enlarged. And the third one is, it is inverted, isn't it? Because it is a reciprocal to the object. And the last one is where actually it is falling. So it is beyond C, isn't it? It is beyond C. The location of the image is beyond C. So here O stands for object and I stands for here the image. So be careful, once again I am telling you. So draw a principal, the light ray which is parallel to the principal axis will passes through the focus, and then if the light ray passing through the focus will become parallel to this principal axis, and you will get the image location at this intersecting point, and by seeing it you can draw or write these characteristical properties of the image. Is it clear? So any doubts? Yes. Here you have to notice one thing, a very simple key point. Okay, blindly you have to remember. When you kept an object beyond C, what about the image location? It is between F and C. Did you notice that? Go to the first video. I have drawn that. When an object kept on beyond C, you will get the image location as between F and C. But here if you observe between C and F, when an object is kept, so where it is getting? So that is beyond C. You understand? So simply it is reciprocal, opposite to each other. When an object is kept beyond C, it will become between F and C. And when an object is kept between C and F, then it will become, the image location is on beyond C. So again the third one has completed. Next we'll move to the last fourth one, that is when an object is kept on F. I have to little bit conscious over here because three diagrams are similar. Three principal ray diagrams we have seen, and this fourth diagram, so this is on F. Be careful. So draw a concave mirror, draw the principal axis, and keep F, locate F, and this is P, pole of the mirror, and this is center of curvature. So what according to the condition on F an object is there, that is like this. Okay, what is according to the principal ray diagrams? So first you draw light ray which is parallel to this principal axis, and that reflected light ray has to pass through focus. Up to that it is same or similar to the previous one. Now the second comes. What is the second ray diagram? Principal ray diagram. When a light ray is passing through the focus, will become parallel. Now observe, how can we draw when a light ray is passing through the focus? Can we draw that? No, directly you have to draw. It is not possible. So that's why I am taking the third principal ray diagram. What is the third ray principal diagram? What is that? Just recall, remember that. That is, when a light ray is passing through the center of curvature, after reflection, it comes back in the same path. And also I have given you there one question also. It comes for 1 mark, 2 marks, even half mark also. Okay, tell me, write the light ray, okay, which passes through the same path even after reflection. At what point it is happening? So that is exactly on center of curvature. That means when a light ray passing through the center of curvature, okay, they never get deviated, and instead that it passes through with the same path. So I have selected C. So from this I have taken a light ray from this tip of the object. A light ray, this light ray, when it touches the concave mirror, again it reflects back with the center of curvature itself, isn't it? So there is no deviation, upward and downward. That is incident and reflected light ray. Once you observe carefully, these two reflected light rays are going like a parallel, isn't it? They are like a parallel. Parallel is nothing but they won't meet. Even if you go on extending like that, they won't meet. So if these light rays are not meeting at a point, do you get an image? No. If there is no image, how can you write these characteristics? No. That's why, what is the answer? You don't know where this image location will be. That's why it is said to be infinity. We call it as infinity. So what is the answer here? When an object kept on F, the image will be at infinity. If an image is falling on at infinity distance, so we don't know where exactly it is going to be fall, so we cannot write, or we cannot even guess the characteristical properties. So that's why its answer is infinity. So this is the only ray diagram's condition which is completely different to this one, isn't it? This is completely different to these three. So here I am choosing a light ray from center of curvature. Did you understand? Yes. So practice, okay, and you will get a small clarity. And in the next video, I will explain you about between F and P. Thank you.